Good afternoon, everyone. Welcome to our Austin Energy Green Building Seminar, Design Build Alternatives. This is our bi-monthly seminar series highlighting topics important to sustainability in the built environment. Before we dive into that information, we'll start with a few announcements of local events and put the direct links in the chat now. Our AEGB e-learning platform offers on-demand courses so you can earn free continuing education credits at your convenience. We upload recorded webinars and other virtual learning resources like tours, workshops, and case studies. Log in to register and see what's new. Austin Energy is testing a new incentive to help address the critical need for sustainable, affordable housing in our community. The passive building incentive will help 4 to 5 affordable townhome or multifamily developments obtain FIA certification. Visit the Speak Up Austin page for details and application information. The SPEAR Policy Industry Workshop is next week. Join SPEAR members, partners, and allies for 2 days of energy dialogue. Exchange thoughts on what's next in energy efficiency, building beyond code requirements, workforce growth, grid modernization, resilience, and more. Step inside some of Austin's professionally remodeled homes during the 20th annual Austin NARI Remodeled Homes Tour on September 20th and 21st. This self-guided 2-day tour showcases 14 transformations from local design build professionals. Check out their website for more details. The 2025 Austin Green Awards has announced the call for submissions. AGA honors Austin's exemplary green building, landscapes, and infrastructure. Nominations for projects in the 5-county Central Texas region are due September 30th. This annual event is scheduled for November 12th, so mark your calendars now. The AIA Austin Homes Tour is almost here. Get your tickets to visit 9 homes on October 24th and 25th. This seminar is being submitted for AIA Learning Units, GBCI CE hours for lead professionals, and AICP for all those that attend this entire webinar. All certificates will be emailed. A follow-up email will be sent with links to the recorded webinar and other resources. It will take a little extra time for video editing for this seminar. We will be adding this to our e-learning platform as well. Here is the AIA quality assurance slide. And these are our learning objectives for our seminar. Today, we'll discuss trends in novel construction techniques in the form of 3D printing and modular construction. Speakers will share real-world successes and challenges they have encountered while implementing these game-changing methods. Our first speaker is Chris Krager with KRDB and Modular. In 2001, Krager founded KRDB, a vertically integrated design, development, and build firm with a mission to create modern, financially accessible architecture that supports sustainable urban growth. Krager is also the founder of Modular, launched in 2008 to expand the reach of sustainable modern design through factory-built housing. Beyond practice, Krager has served as a lecturer at the University of Texas at Austin School of Architecture and has presented at conferences and institutions nationwide, including Hive, AIA, and the Rural Studio. He also co-founded the DBA, Design and Build Alliance, a nonprofit that connects architecture students with real-world experience developing affordable housing for underdeserved communities. I will turn it over to Chris now.
Okay, thanks, Elliot. Appreciate it. Okay. So today I'm going to give an overview of modular, or what I'm going to refer to as industrialized construction, and I'm going to give a just kind of quick synopsis of what I'm going to review today. We're going to start with a little 101 because I'm assuming some of the folks that are watching this may not have deep knowledge. So the first couple of slides might be a bit of a redundant for those of you who who are familiar with the modular world, but overview, we're going to kind of review what it is and how it's defined. That is modular industrialized construction, the different types of industrialized construction, some myths about industrialized construction, benefits, and then a quick tour of the evolution of our firm through the modular space. It's a lot of material, so I'm going to move through it quickly. So please type any questions in the chat for the Q&A. So the word modular, it means something that's designed with a kind of a standardized unit or dimension for easy assembly, repair, and flexible arrangement. But the term, so for example, a 2x4, a wall panel, it could be a pod or a volume, but it's often used interchangeably for the thing we see here on the right, which is a full volumetric building. There's a umbrella term, industrialized housing, which is under the umbrella of industrialized housing. There are three different types of industrialized housing. So there's modular construction, which is what our firm designs and builds, and that's a factory-built dwelling built to IRC or IBC that's placed on a permanent foundation. And then there's manufactured housing, and this is a factory-built product that's delivered on a steel chassis, transported in one or more sections, and it's not put on a permanent foundation, and that's built to HUD code. And then finally, there's park models, which are towable, kind of recreational type vehicles like an Airstream trailer. And that has its own code, which is the ANSI A119.5. So then some of the myths about modular construction, one is that it's less expensive than site-built construction, and this is not true. Essentially, it's at parity these days with site-built construction. Another is that there's no design flexibility with modular construction because of the constraints of what you have in the factory and what you can deliver, and this just isn't true. A seasoned modular designer can achieve just as much as a typical site-built building. That it's poor quality, also not true. These are built in controlled environment under a stringent QA, QC procedure, and so in some ways probably built to a higher standard than conventional construction. That they're hard to finance. This is not true. In almost 20 years of building modular projects, from ADUs to multifamily projects, basically any lending institution of any level of sophistication can finance a modular project. That they're not ecologically friendly. You can achieve basically whatever benchmark of sustainability you want with a modular project. That they're difficult to insure, just like the financing, getting insurance on a modular project. It's treated just like a site-built project. And that they're hard to permit. And again, this is something that it's not the case. These, well, if you're entering a municipality that hasn't seen a modular construction before, it's fairly straightforward in permitting sense. Okay. Next. So some of the benefits of modular construction, you can save 25 to 50% on your schedule. You have reduced time on site, so this is a lower impact on the neighborhood and reduced overhead for the construction firm. Cost controls, you've got predictable pricing and reduced labor costs. Again, the quality assurance, you've got factory controlled conditions. This ensures consistent quality. And from a sustainability standpoint, you've got reduced waste, energy efficiency, and as many green material options as you'd have with conventional construction. So then I'm going to jump into our trajectory as a firm in the modular space. Real quick, some backdrop on this. When we started KRDB 20 some years ago, we designed and built a couple of houses in Austin that ended up in a national publication. We started getting inquiries from people around the country. And after designing houses in Denver and Oahu, New Jersey, and several other markets, and having them come back bid at significantly higher price points than we knew we could build in Austin, we knew there was this latent demand for high quality design at an affordable price point. And that's when we pursued modular construction. I call this our phase one of our modular trajectory. I started calling around factories in the state of Texas and found one in Waco, Patriot Homes, that was willing to work with us and design our first project. Our approach on this, we realized that while there were constraints in terms of how the factory built and what you could deliver, we also wanted to provide, we did not want to forego design. So the initial approach with Modular was taking a kit of parts. And then when we had a client that had a site, a program, a budget, we would assemble a building based on those parameters with the kit of parts that we had developed. The first project we built, I decided I would be my own guinea pig, and we would build a spec house here in Austin. I bought a piece of land and found this company in Waco to agree to design and work with us to design and build this house. About a month into that process, we got word from the company that they were going out of business, and so they were going bankrupt. Fortunately, the architect that was working for them moved to a company in Indiana and said, "We'd like to build this for you." And even though we had to ship it 1,600 miles, the first house we did in Austin, which is 1,500 square foot, 3-bedroom, two bath house you see here, we had fabricated in Elkhart, Indiana, and shipped to Austin with very surprisingly few defects. You can see here it was composed of three modules, one living dining kitchen with a bedroom, a connector module, and then a 2-bedroom, 1-bath module. This is a photograph of the exterior of the building. So after about a half dozen of these projects and having a few companies go out of business, we realized that one of the advantages of modular construction, you need to take advantage of redundancy in the factory environment. And so the factories we were working with said, "Listen, if you want us to build for you, really you need to, not redesign the building every time you come back to us." And so this was kind of phase 2 of this trajectory. I call it the Henry Ford model, where we pared down the offerings to a dozen houses that we would provide. These could all be customized in terms of interior finish, exterior finish, et cetera. But we limited these offerings to these 12 houses. They ranged, we had over those 5-6 years, about 7,000 inquiries, detailed inquiries. And so we pared it down to what we saw as the most sought after floor plans, which range from 550 square foot ADUs to a couple of 2,000 square foot houses. At about the same time, we had some opportunities to explore modular in increased density. So this is when we started designing some what we call missing middle or incremental development projects. And these range kind of from a small, medium, large size. The project depicted here is a 5-unit project we did in Los Angeles in Echo Park overlooking the lake there. So on the small end, we really started focusing on the ADUs or the granny flats in this pivot. These were becoming more broadly allowed and demanded. In California, for example, where we were working, a state law had been passed that required all municipalities to allow ADUs in their market. The house depicted here is actually a true granny flat that we designed for a couple of professors from Baylor that would come down to visit their grandkids on the weekend. The screen porch you can see here in the photograph between the two buildings. On the medium scale, as I mentioned previously in Los Angeles, we started working on we did a series, 4 or 5 projects under Los Angeles' small lot ordinance, which is similar to the home ordinance, which was recently passed in Austin, where you could take a single lot, the lot depicted here previously had one 1,800 square foot bungalow on it, and you could subdivide this lot and put up to 4 fee simple units on that property. This was the 5-unit project overlooking Echo Park Lake in Los Angeles. And then back here in Austin, we developed and designed and built the first modular mixed-use project in the city. This is located on a half-acre tract at MLK and Leona. It was formerly 4 single-family houses, and we built a 24,000 square foot mixed-use modular project there. Project was organized around a courtyard and anchored on the corner with 3 small commercial spaces. Of the 24,000 square feet, 20,000 was modular and 4,000 was site built. There was a podium on the left-hand side of the project here depicted where we parked the project, and then there was a second floor courtyard above that podium with additional units. The project was composed of 3 unit types: a single box 630 square foot 1-bedroom plan, a 2-box 1,330 square foot 2-bedroom plan, and then a 3-box 1,830 square foot 3-bedroom plan. Note that the first and second floor plan of the 2-bedroom and 3-bedroom unit are the same. We were able to complete the volumetric modular allowed us to have these units complete to about 90% in the factory. A couple things that we did in this project that were unique, because this was one of our first multi-unit, multi-story party wall projects. We introduced light chimneys in the project to bring some additional light into the center of the building. And then also, one of the most difficult things in multi-unit modular construction is the coordination of the mechanical, electrical, and plumbing. So we introduced chases, interior chases, where all of the what we call crossover connections were made. We also utilized ductless mini split systems and tankless hot water heaters. These both increased the operational efficiency of the project and the implementation of the project in the field. Here's just kind of an exploded aerial of the project, the site prep, utility coordination, and foundation construction along with the podium were first. You can see the courtyard here in the middle. We also, because we did not increase the impervious cover on this project, we were able to just do a bioswale for the detention requirements. And then on all of the units, 1-bedroom, 2-bedroom, 3-bedroom, all had at least one private outdoor space. And then the 2- and 3-bedroom units had integrated patios that were actually built in the factory with the construction. The volumetric modular construction allowed us to set 20,000 square feet in 5 days. You can see in the photograph here is our site with the stem wall foundations below vapor barriers. And then to the bottom left of the photograph here is the podium over the parking and the crane in the courtyard. We designed the project so that we could fit the courtyard crane in the courtyard. And then we just pulled the boxes up on Leona Street, where we prepped them and set them from Leona Street. And then here's a photograph of the final product. The townhouse construction was all interior circulation, no shared stairs except for exterior stairs up to the above the podium. A corner shot of the project with the 3 small restaurant spaces on the corner anchoring the project, and then there were 2 site-built lofts above that. We've also been exploring some alternative building typologies recently. This is a site plan for a 76-unit 55-plus community, alternative 55-plus community that we have fully entitled in Buda, Texas. It's a 6-acre former organic farm. In the center, we have the old farmhouse that we've converted into a common house along with some maker spaces just to the south. We've got a community garden here, a dog park. You can also see that we've kind of pushed the parking to the perimeter of the project, and the project is comprised of duplex and triplexes consisting of 4, 5, and 800 square foot units. You can see here the depiction of the rendering looking back from one of the porches. All the units have 8-foot front porches, and this is looking back to the common house and the makerspace, and then below the renovation of the farmhouse with an addition of an atrium onto the side. And then here, the cabin units, again, we kind of marginalized the parking and privileged the pedestrian realm with porches on every unit and kind of eyes on the street. We also recently designed a 58-unit hotel project in the Hill Country in Dripping Springs on an 11-acre site. And this is actually a combination of modular typologies. What you see A, B, C, D here is the restaurant, lobby, event space around a pool area, and that's all CLT or cross-laminated timber and glulam construction. And then the 58 units, cabin style scattered throughout the site, are volumetric construction. Here's a rendering pulling up to the main building, the CLT, and then the pool area below with the modular cabinets around the pool area, and then a rendering of the hotel units. And then finally, we've recently, under Austin's recently passed home ordinance, we're about to finish our first modular home project. And this was a change to the Austin Land Development Code that now has 1 family, 2 family, and 3 family units. This is a 50 by 150 foot lot where we are able to get 3 1,600 square foot, 3-story, 3-bedroom, 3-bath units, but also with 18-foot yards between those units. This is a rendering of the project. And then here's actually a photograph of the building. We're coming pretty close to wrapping it up. And then lastly, I just wanted to kind of quickly review some of the things you might want to think about if you are considering modular for a project. One, first of all, what we call a fit test. Is modular right for this project? And that starts with site feasibility, meaning can we get the crane and the trucks there? Are there any impediments, power lines, trees, et cetera? And then also like the project typology, do the spaces work with modular construction? Also crucial, integrated design. I can't emphasize this enough, and engaging the factory early. This is having your team on board early, your architect, your structural engineer, your MEP, your civil, hopefully your general contractor as well. This is key to the success of a modular project. Design for manufacture and assembly, understanding and knowing how the manufacturer works, what their systems are, and what you need to conform to. Knowing your code pathway. For modular, they can be IRC or IBC. Most factories do either IRC projects, which are basically residential up to maybe 4-unit townhouse, but some factories do both IRC and IBC projects. What your permitting strategy is, can you have your site permit working in parallel with your factory approvals? And the one thing that is different about modular is that you are getting the factory portion approved by the state agency. In the case of Texas, that's the TDLR. What your logistics plan is, making sure you coordinate with your crane and your set crew and your factory. Understanding foundations and tolerances with modular construction. Similar foundations, but you have embedded tie downs and things like that. Cross-checking your actual as-built dimensions in the factory with your foundations, where things are landing, et cetera. Freeze dates and changes in design. Obviously, because you're building maybe 50% of the project in the factory, it's not like site-built construction where you can make changes on the fly. Understanding contracts and responsibilities, making sure there's a really good, what we call resume of work. The factory knows what they're doing. The local GC knows what they're doing, et cetera. Costing and cash flow progress payments are tied to production and transport. So this really relates to financing and making sure that you connect with the bank up front, and so that you know how draws are going to roll out. Quality and inspection. All the factories have their own QA, QC manuals that are mandated by the state of Texas or whatever state you're building in, but understanding these and also scheduling your inspections in the factory and having your own quality assurance program. And then lastly, of course, because this is an Austin Green Builder forum, with a modular project, if you want to attain 5-star or LEED Platinum, basically any level of sustainability you want to achieve with a site-built project, you can, for the most part, achieve with modular construction. So I'm going to stop there. Okay.
Thank you, Chris. That was great. Just a quick reminder before we move into our next segment, if you guys have questions, please submit them into the Q&A box so we can answer those at the end of the webinar. Okay, our next speaker, Bungane, is Director of Building and Construction Science at ICON, leading the development of the engineering and performance fundamentals of the core building blocks for structures created with ICON's technology. His focus is on establishing the core building and construction science principles and approaches that advance the construction industry, positioning ICON as the leader in performance and durability standards for 3D printed structures. Bungane remains an active member of the built environment community and remains committed as a co-founder of the Austin Green Awards and ULI Texas chapter representative to the High Performance Building Design Evaluation System Advisory Committee for the Texas State Energy Conservation Office. So I will turn it over to you, Bungane.
Sorry about that, Elliot. Am I back? Can you hear me?
You are back, yeah.
It was super weird. It just like froze for 1 second and then came right back. Thanks for the introduction. Let me pull up my presentation here. Thanks again to Austin Energy for hosting these events. So wanted to provide an introduction to 3D printing construction. We'll cover a bunch of material here and look forward to talking through people's questions towards the end. So ICON is a construction technology company focused on creating the technology that allows us to deliver high quality performance homes. And that's important. I'm going to talk a lot about 3D printing construction today, but we're really interested in like all types of construction technology. And so I was really interested in listening to like Chris's presentation and the experiences that he's had over time with deploying like modular and what works from a scaling perspective. And so the idea behind 3D printing construction is to be able to deliver higher performance. So when we're talking about housing, being able to provide a higher quality home product with faster construction and at a more affordable and cost competitive rate. Today, our technology is comparable or competitive with most framing methods, except for those that are like the largest volume builders who have a lot of advantages when it comes to the suppliers and the trades that they're able to lock in. But we're cost competitive right now from an overall delivery perspective for the walls. There are a lot of factors that go into the cost related to the location of the site and the amount of printing that's actually being undertaken. And the idea is that we want this to be beautiful construction. We want it to be sustainable and more resilient. And I'll talk a little bit about some of the ways that we think 3D printing construction is able to achieve those aims. But like from a company perspective, one of the things that's a little different about how we approach things, and I think if you're considering 3D printing construction technology for a project, is important to consider is sort of who is providing and where do the robotics come from, where's the material source from, and the understanding of the design and the software side. So ICON is fully vertically integrated in the sense of we design our own robots. We have developed and actually supply all of our own material for the Central Texas region. And then we also have in-house architects and structural engineers who are familiar with how to design with 3D printed construction. And then all the software that was used both for taking an architectural design from design to print, as well as all the software to actually run the printers is developed by ICON. A lot of folks that are out there doing 3D printing construction, I think this is just like if you're going to work in that area, is make sure that like there's an understanding of like how all those different parts fit together. One of the things that we've learned over time, and you see it cropping up in the industry, is that putting one type of material through one printer, one manufacturer's printer, and then taking that same material and putting it through a different manufacturer's printer actually yields a different result. And so like being able to understand those interoperabilities is a really important part of 3D printing construction. So jumping right into it here with a little video to get some visuals. It might be choppy a little bit to start, but in our trials, it generally went well. To give you an idea, like what is 3D printing construction? So what you're looking at is our current generation printer, our Vulcan printer setup. It's a gantry style. And you can see what the printing process looks like. This is from a variety of projects, mostly actually in the Austin area. This video was shot, but some of them in other locations. And you can see that we're extruding the material. It's being put down layer by layer. It is almost in some ways like a large format of a desktop printer, and just printing with a different construction material. This is some testing that we've done on our site here. This is the Cosmic Pavilion that's going up that you can actually see outside the Long Center today. So what I'll do is I'll go through and like talk a little bit more about like what the technology actually is, what is this Vulkan printer, and how does it work. But it's often helpful for people to actually like see what is the process of 3D printing to understand it. So Vulkan is the printer that we are working with today. It is a gantry style printer. And if you look across the 3D construction space, it is really like it was the most common printer that you saw. And the reason behind that is it's actually like a very stable engineering platform to set up. It has two vertical towers that we call the Z towers, an X-beam, and then a shuttle that moves back and forth. And like, so it's a very stable platform. It's easy to understand the coordinate system. And it is like fundamentally like an easier engineering platform to stand up. From a space perspective, so our gantry style printer is capable in a single setup. We're able to print a maximum of 40 feet and about 120 to 150 feet in length. Now, what we have actually done is we've taken this printer setup configuration and actually overlaid it on each other to create both larger structures, commercial buildings, as well as residential homes. And the form factor for this size of printer was driven really by two needs. One, the 40-foot width roughly generally fits like the minimum lot size that you see for production home development. And then the other factor is that the form and size of this printer was able to fit inside of a shipping container, and we were able to deliver it to site effectively with two vehicles. One vehicle bringing the Magma, and then the other bringing the Vulkan printer. So this is what a construction site. If you went out to Georgetown about 2 years ago now, and you saw us underway printing, we printed 100 homes out there. This is what it would look like. So there's about actually 8 printers set up in this shot here, and really it is a in-site. The method that we use is like in situ. We're building on-site construction, and so what it really means is like every site is like a little mini factory. And so in the foreground here you can see the Vulkan printer. And then this white box over here, I mentioned Magma. That is the material batching system. So the way that works is that these bags, like these white bags here, bring in dry mix material. They are mixed inside Magma with water, some other additives. And then that Magma pumps the material out to the Vulkan printer, and it goes back and forth and deposits the material. The robotics is the big piece of equipment that is very interesting to watch. Having watched probably like hundreds of hours of printing at this point, it doesn't actually get boring over time. But a lot of this, the secret magic sauce and the work and the material science occurs in Magma itself. A couple other things to call attention to here is that one of the things you actually don't see a lot of is a lot of people. So today we are operating a single Vulkan printer setup with 2 operators. On larger sites, we will have like a third person who is serving multiple printers, providing field support. And with those 2 operators, they are basically able to complete all the printing activities that are necessary. A couple other things is you'll see that there is the printers are set up in rails, and so one of the things that we do is we are able to deal with slight grade change out at Wolf Ranch. Pretty much every home had some slope, and you can see that we have crane mats, and then we have geofoam set up, and then in the foreground you can actually see some light leveling pedestals that the rails are set up on. So every printer, so 2511 here in the foreground, every printer has 2 sets of rails. It has a set of rails that it's operating on, and then it has the next set of rails that are positioned in advance of its arrival. So we do a rough leveling, positioning of the next set of rails. The printer is then brought onto the site, and we do the fine positioning at that point and fine leveling. It takes It takes us with the gantry style printer, it takes us about 2 days, a day to 2 days to be able to set up the entire printer and getting ready to what we refer to as like nozzle open. And that is one of the limitations of the gantry style printer. It is in a fixed position. If you want to build a bigger print volume or bigger print bed, you need a bigger printer if you're going to go with maintain with like the gantry style architecture. And so that this is actually like a site of Wolf Ranch, and today all of these homes are now completed, and they've actually all been sold. And we are just getting ready to print these last two homes that are going to go in this parking lot here that were next to the model units. But that really brings us to our next generation printer, which is going to be a multi-story printer, and is is on an articulating arm on a tread pedestal. So what this does for us is it eliminates the rails. Basically, we've removed the confinement of the rails, and it allows us to basically build more than twice the print volume from a single setup. So what you're seeing here is a comparison of those two 40-foot. This is about 100-foot length of home in a single setup. And then this printer also is able to go up to 27 feet high, and then it can actually print 4 feet below grade. So like the big advantage of the articulating arm is obviously your print volume. You're not being constrained by the rails, but also from like a setup perspective, one of the challenges with a gantry style printer is the logistics of like moving the rails and moving the towers and setting up the towers and getting the towers leveled. This next generation printer is on a self-propelled platform. It will take the hours to be able to set up. We expect it'll take somewhere in the range of 3 to 4 hours to be able to go from pulling up onto the site to being able to get ready to start batching material and printing. And then from a time perspective, so for being able to print a 2,000 square foot home, it takes, if we're able to print 24/7, which is something we can do with our print system and is actually the most efficient aspect of it, we can deliver that in about 7 days. When we're working sort of more typical, and if we're in a more urban area, we're printing from say 7 to 9 or 7 to 7. That expands out to 10 to 14 days, depending on weather. So this is the prototype of the next generation printer that printed what we refer to as the House of Phoenix, which is down in South Austin across from our headquarters off of St. Elmo. So what are we printing? So we are printing a wall system. And so when the company was founded on the idea of like creating more resilient housing, being able to create and select a technology that could scale that had widely available materials. So the wall system that we're working with is basically it's a concrete wall system. What we're printing with is actually a cementitious mortar, and the main difference between a mortar and concrete really comes down to the aggregate size. Is the biggest difference. Concrete has larger aggregate. And so we're going along and we're depositing layer by layer. We're creating two shells. So there's an inner shell and an outer shell. And then on alternating sides of each one of those shells, we are printing what we refer to as cores, or also sometimes referred to as pilasters. And then inside those pilasters, we're putting a piece of reinforcement, and we're grout filling that cell. So the spacing of these cores varies on the structural requirements, wind loading, height of the wall, and that sort of thing. But in general, they're spaced roughly every 4 feet, and then on either side of window and door openings around the shell. And across the top of the wall, there's multiple options. We have done and can do a bond beam, which is similar to CMU construction. We can also have done wooden top plates. We've done rim beams, and all of this sits on a conventional foundation. So you have a conventional foundation at the base. There's a piece of rebar that we embed into that epoxy and then embed into that foundation. And then that piece of rebar coming out of the foundation is lap spliced and connected to this piece of vertical reinforcement that is inside the grouted cells. And those cells get grouted up to the top of the wall, and then you have a top of wall connection that your roof is able to attach to. So that is basically, for those of you who are structurally minded, that ends up being what your load path looks like. It is a fully reinforced system. So one of the questions that often comes up about 3D printing construction is like, is there reinforcement? As far as I'm aware, that, all the systems in the United States are reinforced. There are some companies working internationally that work with unreinforced 3D printed systems. But generally, the building codes in the US require reinforcement for concrete systems, and even some level of reinforcement for masonry systems. So there's really three types of reinforcement that we have. I've already spoken about the piece of vertical reinforcement that runs down inside the cores. There are also cross ties that connect the two shells. So that allows for load transfer from one side of the shell to the other for wind loading. And then what you see in these fine black lines is actually the horizontal reinforcement. I don't have it in this deck, but one of the technologies we've developed is actually the ability to print reinforced concrete. And so what that means is that as we are actually extruding the printed material out of the printer, there is a 7x19 wire aircraft cable, basically a piece of aircraft cable that is embedded inside that print. And so this horizontal reinforcement gets inserted as part of the print. There still are some manual pieces, but one of the things that allowed us to do is it basically took us out at Wolf Ranch. We were at over 3,000 pieces of reinforcement, and we've now reduced that down to a couple of hundred manually horizontal placed pieces of reinforcement. From a moisture and like weather barrier perspective, this system relies on a barrier wall approach. And so the exterior concrete shell is where your weatherization barrier occurs. And we have done moisture control vapor barrier testing. It is technically a class 3 vapor retarder and with a perm just over 1. And then on the exterior side of the wall, we actually did some field testing of just like the bare material itself. And it actually did a pretty good job of actually preventing any rainwater penetration. But we also do apply a clear coat sealer to any of our architectural exposed finishes where there's no paint on the wall. And then we use a painted waller, like a block filler system that goes on the exterior of the wall. And then the perimeter, we have a slab slope. And then inside the wall, the overall thermal performance ranges from R17 to about R22. And that's overall thermal performance. And so for those of you that are familiar with U factors or R values for masonry walls in our climate zone, I believe the code value here is R6 of continuous insulation. So from a masonry wall construction or a mass wall construction perspective, several times better than what you see compared to code. So this is an engineered and tested system. So this is sort of leading into, from a code compliance perspective, these walls have been tested for high velocity wind zones. That wall system I showed you has achieved a over 2-hour fire rating. There is no wood involved in the structural system, and there's no organic material that promotes any mold growth. And so we've actually done a fair bit of full-scale testing, and I'm going to let this short video play through. This shows some testing that we actually did coming up on 4 years ago, and we've done several other iterations of this with our newer wall systems, and we've tested these walls all the way to failure. Full-scale samples. This is axial loading. Before that, you saw flexural loading, shear loading to understand the engineering properties of the wall systems themselves. And this is a version of our wall system going against 2 double shells and doing a tornado test where you're throwing a 2x4 at the wall at 100 miles an hour. So for the high velocity wind zones or hurricane winds, you toss a 2x4 that's a little bit lighter and you do it at about 30 miles an hour. And this is showing what happens at 100 miles an hour. And so the opportunities for being able to use it for tornado shelters. So in approval permitting perspective, there are a number of different organizations that are working on both standards for 3D printing construction as well as code language. Both ACI and ICC have draft language that is out for public comment. Can't remember if the comment period has closed. at this point to introduce into at least the IRC code language for 3D printed construction. ACI, I think, is going to take a little bit more time to work through the language for commercial applications, but there's no like current building codes associated with it. And I'll go through what the code compliance path is here in a minute. But this is actively underway, and in the 2027 cycle, we expect to see a section introducing 3D printed construction. For those of you that are familiar with some of the appendices that exist in IRC 2021, Appendix AW, there was a clarification that was basically issued that is not intended for use for cementitious 3D printed construction. There was another company that was working with thermoplastics, and they developed the testing protocols that were tied to UL 3401, which became Appendix AW in IRC 2021. So all the structures that ICON has completed have been permitted and designed by a licensed structural engineer. And the most common compliant path that actually we have taken is through the engineer of records stamped construction documents and AHJ approval. We have also gone through the path of working with ICC evaluation services and developing and going through their AC 509, so acceptance criteria 509, and getting an engineering service report. So there are paths for achieving code compliance. It's section 104.2 in both the building and residential codes. And so like today, you can go online to ICC evaluation services. You can find their evaluation services reports. You can search for ICON, or you can search for 4652, and you can find both our 3-bead wall and our 2-bead wall now is actually included in our ESR. And so this is information that we can provide to other jurisdictions or any building officials who have further questions about the engineering system. So touching briefly on like wall system and enclosure design, because I think they'll be of interest in just the closing minutes before we just flip through some projects that are around Austin. From a weatherization perspective, we have we're installing a jam that can be framed, it can be metal. We are then flashing using liquid applied flashing to go from that framed jam member onto the printed wall to deal with the scalloping or the uneven nature of like the print coming up to a framed member. And that's how we're basically able to continue our weatherization barrier onto a window or door condition. For plumbing, we've taken the approach of making sure that any plumbing connections are exposed and accessible behind otherwise conventional materials. So this is showing how rough blocking is put in for a shower, and then you basically put your standard shower surround, whether it's an insert shower or tile or plaster or whatever you want to put inside your shower to cover that up. So it still remains fully accessible. It's understood by the trades. And a similar approach taken for toilets, and then behind vanities and the like, making sure that you can see the print actually like turns in and there's framing and blocking there. Electrical, what we are doing is creating an opening that gets cut during construction, during the print process. And then afterwards, the electrical contractor is able to come back and put in what is effectively like a masonry box and install that inside of the wall. And then for low voltage, these are just core drilled openings using Smurf tube if it's an insulated wall, or fishing wire for any surface mounted devices. So want to run through some projects with a heavy focus sort of on Austin. I think it's like, it's actually, ICON would not be where it is without the support of the city of Austin and the building officials at Austin to like take the time to understand how our system works. One of our first customers and continuing customers today is Community First Village, where we have completed, we're probably close to having actually completed 100 dwelling units for them, 100 units for them. And by the time we're finished, we'll be closer to, I think, about 120, 130 units that we've done out there. So these are some of the first homes that ICON did. The first person, as far as we know, to live in a 3D printed construction was out at Community First Village. These are some of the newer units that we are delivering for them today. So East 17th Street, actually not too far away from that project that Chris was showing. This was our first project for sale homes. And then you also notice that it's frame construction above. So this was to understand sort of market acceptance and how the wall system integrates with the second floor. And so these homes have actually been sold and resold at this point. And then House Zero. So this is a home that is down in East Austin. There was really a tipping point from seeing like the way that 3D printing construction can be developed. So this was custom home, higher end home, intentionally designed, purpose-built around 3D printing construction by Lake Flato architects. And then, of course, Wolf Ranch. And I actually already showed you this shot here. But these homes are for sale. Been quite a successful community for Lennar. And they've announced that we're going to be doing another 200 homes with them next year, also north of Austin. This is a commercial project that's actually out at Camp Mabry. And so this is an example of like an architectural exposed printed finish where just the clear waterproofing coating was applied on the exterior. And then I think this is the last project I have on the list before we wrap up for questions and comments. These residences are actually under construction right now and actually being printed right now in Mueller. So off of Tom Green in sort of the southeast corner of the development, just off the Greenway. And so this is a series of market rate units as well as affordable units, consistent with the way that Mueller development was conceived. So this is actually an opportunity that if you're in the area, you can actually go and see some active 3D printing. I believe that's the last one.
All righty. Thank you so much, Bungane. Appreciate it. I'm going to invite our speakers to turn on their cameras, and we're going to get some Q&A out of the way with the remaining 10 minutes we have. All righty. We got quite a few in the chat here. I'm going to start off with a question for Chris. Can you speak to the integration of fire sprinklers into the triplex multifamily units or triplex multifamily units? Any specific issues with their installation?
No. So fortunately, what we use, so we'll use a couple different companies we use, but typically we're able to set up a contract where the fire sprinkler contractor does the rough install on the plant. And then they are also coming out, and when we set the mods, making the crossover connections and getting the system all set up. So we've had no issue with fire sprinklers in mods.
Thank you. Bungane, this came in during your presentation. Are there any additional considerations for foundation design when utilizing concrete construction? Oh, I think you might be muted.
Thanks, Habit. Yeah, no, great question. I'll answer like the question directly, and then usually there's also like a question around there around like expansive soils, especially where we are in Texas. So the foundations that we're designing right now, there's no like additional considerations in terms of the size, depth, or strength of the foundation compared to framed. The main consideration still is like what soil type is it sitting on. And so from a foundation design perspective, we are both when we're just executing the printing work or when we're also designing, printing, and then finishing out the homes like we are in Mueller, making sure that we're understanding what the soil type is and then designing the foundations appropriately.
Gotcha, thank you. Another question about the printer. Can the multi-story printer print basements?
Yeah. So the way that the current printer can go about 4 feet below grade. Now, the question on basement walls is, can we print on top of a basement wall? Definitely. I think the part that we'll work through in the coming years, and especially as we move into markets where basements are more prominent, is the value add of being able to print the basement walls. And like I think as long as there's like a positive value proposition there to like be able to print the walls, it is something that can be done. We could also do retaining walls or like homes in the like the hill country where you have you might have 10, 12, 15 feet of just a retaining wall for the home. Like we could print that retaining wall for the foundation and then have the rest of the home be printed on top. So like the printer in that case would be situated like next to the home and be able to do that print.
Got it. Thank you. Another question, are the shells mixed with lightweight gravel mortar? Do you typically see beefier foundations than conventional wood frame construction?
Yeah, so the shells is a proprietary mix. So it's not a gravel mortar. It is a mix that is made up of a couple different types of aggregate, cement, water, additives, and some other supplementous. I always get chuck of those. SCM, supplementous cementitious materials. Tongue twister on that. but yeah, that's what the mix is. But it's not. So we're not printing out of a ready mix. The next generation printer will be able to accept a wider range of mixes, and like the real idea of that is to be able to work with local materials, different types of material. And we have actually done a bunch of research to identify other types of mixes that are more regional in nature, because we don't want to be we're not in a position where we have to be shipping everything from Austin.
Got it. Thank you. Next up for both presenters, I'll start with Chris. How friendly are the systems for renovations? I think about homeowners and handicapped people, I'm assuming. Yeah.
Well, we do not do custom single family design in modular. So now if someone has a house and one of our units would work as an addition to the residential addition to their house, we can do that. There are firms that do custom residential modular. We just don't do that. So conceptually, yes, it can work. It just has to conform to what your pre-existing conditions are.
Gotcha.
Yeah,
and then I'll turn it over to Bungane. Yep.
Yeah, and on the 3D printing side, so in terms of being able to if you wanted to add on to your home, today, with the way our technology is set up, we could work with you to do something to do a lift in place if you wanted to have a printed exterior, or you could add on with conventional material. So you could add on with a CMU block, you could add in with framing. In terms of creating an opening or removing interior partition walls, that is something that you could do. You just need to work with a licensed structural engineer that could identify, make sure the wall's not structural. In general, for most homes, only the exterior walls are load bearing, but it is something that can be done. I will say, one of the things that we are engaged in is we actually have an Icon Owners Association that stays in touch with homeowners, and so there is a need in to have people who are familiar with how to work with the walls, how to do repairs. There was a question I think I saw about hanging up paintings or anything, wall hangings on the wall. Homeowners can actually do that from home, just going down to Home Depot. All the materials they need are available there. We actually have some YouTube slides. But then there are also some owners who want somebody else to do it. And so we've actually started to work with and identify folks that are able to do that in the Austin market. And as we continue to expand, we'll provide that same level of broader homeowner support to improve the homeowner experience.
Great. Gotcha. Regarding modular homes, have you looked at past attempts to get inspiration, thinking specifically about Listron homes and their use of a set size of enameled steel panels to aid in manufacturing, etc.?
Yeah, I mean, prior to embarking on this endeavor, obviously there's 100+ years of history of architects attempting this. Some of the most famous architects, Gropius, Buckminster Fuller, et cetera. One of the things that the conclusion we came to, one of the primary reasons none of these things ever were realized in a kind of meaningful way was the insistence on invention and not trying to work within the kind of pre-existing systems. And most modular factories are building stick frame construction. And so, while we've been able to achieve kind of baby step incremental changes with these modular manufacturers in terms of how they work, most of the product that's coming out, certainly on the residential side, is fairly conventional construction methodology. So it's a little bit of an uphill battle, and there's a reason for that. There needs to be scale for adoption on that.
Great. Thank you. And then one last one before we wrap up here. For printing, can multiple small structures be printed simultaneously?
Yeah, definitely. So the best example actually was the Community First Village homes. Actually, the first ones that we did, the ones that had the colorful exteriors, those were actually printed 3 at a time in a single setup. And then they have some smaller or similar size townhome structures that we're delivering for them right now. And we're printing at least 2 of those in a single setup. So yeah, yes, it's possible to change, and it also doesn't even have to be the same floor plan, right? So you could actually like do 2 different floor plans in the same setup, and that's definitely something that's possible. And we look for, like, I think that is where the great flexibility of the next generation printer will come from. The multi-story printer is that you have a much larger print volume where you can build 3 or 4 different structures and different floor plans for smaller homes in like the same print setup.
Fantastic. Okay, great. Well, thank you very much, Chris. Thank you, Bungane, for your time and your
Thanks for
knowledge
having
in
us.
answering these questions. I appreciate it very much. I will turn it back over to Elliot to wrap us up.
Yeah, thank you to everyone for attending. Please take a moment to complete the survey link placed in the chat. Your feedback is greatly appreciated and helps us plan future webinars. As a reminder, everyone registered will receive a follow-up email with resource links and a webinar recording. Today's webinar attendees will receive a continuing education certificate for self-reporting GBCI CE hours and AICP CM credits. If you provided your AIA number during registration, we will report your AIA LU for attending this webinar. If you couldn't attend the entire webinar or want to share this information with colleagues, this seminar will also be added to our e-learning platform in about 6 weeks, where you can watch the recording, take a quiz, and earn CEUs. Check out the current courses at this link in the chat and log in to get started. Thank you all again, and this concludes our webinar.